everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about definitions and terminology on module 5th, AC machines, that means induction motors and synchronous generator, that means alternator. So now in the total 15 definitions and terminologies. In that first one, in the AC machines, module 5. So mention the material used for frame of induction motor is made. That is made up of with cast iron. So it acts as a yoke. Means yoke main purpose is it provides mechanical support for the stator winding, and it acts as a protective cover the whole machine. For that purpose we are using cast iron material we are using for the frame of induction motor, that means yoke. Now the power factor of the induction motor depending upon the area between stator and rotor. So this is the stator, means it is actually a stator and rotor. So the power factor of the induction motor, that is depending on area between this area, depending upon the area, so power factor varies. Now the material is here cast iron. Now second question, cogging. What do you mean by cogging? Cogging means when, so see this diagram first here. So this is the stator frame, this one, stator frame, and it is a stator having number of slots here. These are the slots. This is the stator and these are the slots. So this green color indicates stator slots. So now here these are the slots. And this green color circles are windings. So this stator slots carries the stator winding, and this is the rotor. In the induction motor always is rotating part is rotor and stator part is the rotor. Stator having stator winding and rotor having rotor winding. So this red color circles are the rotor winding, and these are the rotor slots. If suppose rotor slots equals to stator slots, so what will happen? At the time of starting, there is a magnetic locking in the induction motor due to when stator's teeth, means stator's rotor slots equals to this one, number of rotor slots is equals to number of stator slots. So at that condition, so when number of stator slots is an integral multiple of or is equal to or an integral multiple of rotor slots, and at that case induction motor fails to start. So this phenomenon is known as cogging. So it should not be not equals to integral of stator slots and rotor slots. So this is important. So this condition, this phenomenon is known as cogging. Now third question in the AC machines. So why voltage regulation for alternator operating at leading power factor is negative? So see here. So here voltage regulation of alternator operating at leading power factor is negative due to magnetizing nature of the armature reaction. So here percentage regulation, so that percentage voltage regulation equals to E0 minus V divided by R. So here we can write this IR cos phi plus or minus IX sin phi divided by V. If it is positive for lagging power factor, and if it is negative for leading power factor. Now this leading power factor, because of this magnetizing nature of the armature reaction. So armature reaction may happen in the alternator. So because of that armature reaction magnetizing nature, there may be a leading power factor. After that, because of that leading power factor, so there may be a negative voltage regulation. There may be a voltage regulation. Now, fourth question. So, mention the most prominent component of base loads. That is synchronous machine. So, synchronous generators or synchronous motors are main generating section of the power plants. So, here for base loads, there are two types of loads. So, peak loads and base loads. So for peak loads, we will use DC. Sometimes we need some urgent power during some period. So we need maximum. We need for peak load purpose, we will use diesel power. And for base loads, we will diesel generators are the best examples. So diesel power plants are the best examples for base to generate for peak loads, for base loads, for synchronous generators. Fifth question. So mention the function of AC generator. What do you mean by generator which converts from mechanical energy to the electrical energy is known as generator. If it is generator AC, that is AC generator. So see this diagram. So now, which converts from mechanical energy to the electrical energy, that is generator. If this electrical energy is known as, if this electrical energy is AC, that is known as AC generator. Now if you see the definition, see this one. So AC generator is also known as alternator or synchronous generator. AC generator is also known as alternator or synchronous generator, that machine which converts from mechanical energy to the electrical energy. So which converts from mechanical energy to the electrical energy. If that is AC, that is AC generator. The electrical energy is in the form of alternating current sinusoidal output. It should be alternating current, and that is sine waveform or sine output waveform. And that mechanical energy usually supplied from the steam turbines. So that we know, so it requires mechanical energy. That mechanical energy is in the form of steam, or we can use gas turbines and combustion engines. So which converts from mechanical energy to the AC electrical energy is known as the machine is known as DC AC generator. If it is generates the DC supply, so if it is generated, that is DC generator. So this we can convert. If you use commutator, then we can convert from AC sine wave to the DC supply. So that is DC generator. If commutator is present, that machine is known as DC generator. And next, list out the main parts of AC generators. What are the main parts of the AC generator? So every machine, every generator or motor having stator and rotor. So stator and rotor. Stator having some parts and rotor having some parts. So in this, so there is a relative motion to takes place between magnetic field and conductor. So rotor is a part of rotates. So what does it mean here? so there must be relative motion in the generator. So E is directly proportional to the d phi by dt. So d phi by dt means there may be a change in flux. So the phi1 minus phi2 divided by t1 minus t2. There must be change in flux. So if there is no relative motion, that relative motion is zero means, so there is a flux cutting is zero. So always flux should not be constant. So to maintain that varying flux, so there must be relative motion. Either stator winding, stator is so conductor and flux. So either it should be conductor should be stationary or flux should be stationary. One should be rotating and other one should be stationary. So in case of DC generator, or DC motor, so in case of DC generator, so field winding, so flux, magnetic field is stationary. Conductor is rotating. So now here, so one is stationary, field winding, magnetic field is stationary and conductor is rotating means, so there may be a change in flux. Rate of change of flux. So flux cutting is changing, so change in flux and rate of change of flux d phi by dt, then induced EMF will be developed in the armature conductor according to the Faraday's law. In case of AC generator, reverse case. So armature is stationary, so conductor is stationary, so opposite, these two are opposite. So armature is stationary, conductor is stationary and magnetic field is rotating. So in that case, so flux is rotating means, so conductors are stationary. In the conductors are stationary, this flux cuts the rotating flux cuts the armature conductors, stationary armature conductor. Now there may be a induced EMF because of there may be a change in flux and there may be a rate of change of flux and induced EMF will be developed in the stationary armature conductor. Here in case of DC generator, rotating armature conductor. Now here the most important parts are stator and rotor. In the AC generator, stator parts are armature and rotor parts are the field winding. Now, seventh question. So mention types of AC generators. So AC generator types are induction generators and synchronous generators. Now here depending upon the supply. So if it is AC DC supply and if it is generates AC supply, DC generators and AC generators. In the AC generators again classified as induction generator and synchronous generators. Or these synchronous generators are also known as a alternator or AC generator. Now 8th question. So is commutator is present in the AC generator? No. So in the AC generator, it converts from mechanical energy to the electrical energy. That electrical energy is which AC generator is this is electrical energy from mechanical energy to the electrical energy, that is AC. So sine wave. So in case of DC generator, there may be a commutator which converts. Commutator main purpose, it will convert from bidirectional current to the unidirectional. That means which converts from AC to the DC. But there is already AC supply, so it does not require any commutator component in the AC generator. So commutator is a device, so for reversing the direction of the current flow, electric current flow of current, and it simply converts from AC to DC. Already it generates AC, it does not require any DC supply. So here it does not, in case of AC generator, it does not require any commutator. Now, but here in the alternator, we need only AC. So there is no need of commutator in the alternator. That means AC generator, synchronous machine. Next, ninth question. Which rule is used in the AC generator? So here Fleming's right hand rule for AC generator and Fleming's left hand rule for AC motor or DC motor. And for AC generator and DC generator, we will use Fleming's right hand rule. So Fleming's right hand rule. So in that, so what the Fleming's right hand rule means? So here thumb finger and forefinger and middle fingers are right angles to the each other. So this is a right hand. So thumb, forefinger and middle finger. So here thumb direction, thumb is indicates the motion of the conductor, and this middle finger, this forefinger indicates the magnetic field, and this middle finger indicates the direction of current. That means generated voltage. Now here, see here, this direction of induced current when attached to a circuit moves in the field, magnetic field, it can be used to determine the direction of current. So the main purpose of this Fleming's right hand rule here to determine the direction of current in the armature winding of the AC generator. The main purpose is to determine the current direction only. So here that middle finger direction is the current direction. That you need to keep it in mind. Next, 10th question. How can a generator produce more electricity? So how can produce more electricity? Depending on the number of tons. If we increase the number of tons, number of conductors, then we can increase the electricity. And if you increase the flux, magnetic field, then only we can Zn phi by 60 into P by A. So number of poles. So in case of DC, in case of AC also same thing. If you use here, number of tons increases, number of conductors increases, and then when we can increase the EMF, and if we increase the flux magnetic field, then we can increase the EMF, and if KD and KC factors also, then we can increase, and this frequency increases also. We can this induced EMF in case of AC, that induced EMF is also depending on the frequency also. So it is depending on magnetic field, number of tons, and frequency. So you can increase the output voltage of the AC generator. So rotating it as a factor, increasing the number of tons on the coil, this one, and strong magnets. If you use strong magnets, and the strong magnets having strong magnetic field and strong magnetic flux. So mention the working principle of induction motor. Induction motor working principle is the revolving magnetic field and magnetic induction, electromagnetic induction. If you see, so it works on the principle of electromagnetic induction. So the motor which works on the principle of induction motor is known as induction motor. So the electromagnetic induction phenomena in which electromotive force EMF induced across the electrical conductor, which is when it is placed in a rotating magnetic field. So now in the induction motor, this is the induction motor. If you give the three-phase supply, if you give AC, that is three-phase AC supply, that is RYB. So if you give three-phase supply to the stator of the induction motor, there may be a rotating magnetic field. That means revolving magnetic field. Rotating magnetic field will be developed in the stator of the induction motor if you give the AC supply, three-phase AC supply. Now here there may be a rotor. So rotors are already short-circuited. So rotor conductors are short-circuited. Now here, according to the electromagnetic induction, so this revolving magnetic flux cuts the rotor conductors and induced EMF. Induced EMF will be developed in the rotor conductors. Induced EMF will be developed in the rotor conductors according to the electromagnetic induction. So this is rotating and this is a rotating magnetic field. Now induced EMF will be developed in the rotor conductors, means rotor conductors are short circuited. So short circuited means there may be a closed path. So induced EMF is there and there may be a closed path and there may be a current. So rotor conductors carrying the current. So rotor current carrying the current means current carrying conductor is always acts as a magnet. So this rotor is acts as a magnet. So now we have two magnets here. So one is rotating magnet and another one is an electromagnet. So due to the attraction or repulsion force between this revolving magnetic field and this electromagnet, that means rotor conductor. Now there may be an attraction force or repulsion, that means mechanical energy, which converts from AC electrical supply to that mechanical attraction or repulsion force, that is mechanical energy, which converts from AC three-phase AC supply to the three-phase mechanical energy to the electrical energy to the mechanical energy, is known as induction motor. So now 12th question. List out the stator main parts of the induction motor. So see here. So here stator of the three-phase induction motor consists of three parts. So stator frame, stator core and stator winding, that means field winding. So this is the stator frame. So stator frame having these slots. These are the slots, so in which we can accommodate the stator winding. That means these are the stator windings. These are the stator windings. Now this is the stator core. Stator core and stator frame. So it is made up of with cast iron, and stator winding made up of with copper. So stator core is made up of with silicon steel. Now here this construction is known as the stator of the induction motor. Again in this rotor is placed. Rotor rotates inside the stator of the induction motor. It is also having rotor slots. So rotor slots we can accommodate the rotor winding. So if you give three-phase supply to this stator winding, rotating magnetic field will be developed, and that rotating magnetic field cuts the rotating conductors, and induced EMF will be developed in the rotating conductors, and so rotor conductors are short circuited. So rotor currents produces that rotor according to the right hand thumb rule. Flux generators, it acts as an electromagnet due to the attraction and repulsion of rotating magnetic field and electromagnet, and mechanical force will be generated. 13th question. List out different types of three-phase induction motors. So first one is a slip ring induction motor, and second one is a squirrel cage induction motor. Slip ring induction motor, another one is a wound rotor induction motor. Wound rotor induction motor. So depending upon the applications, so we will use squirrel cage and slip rings. So now here slip ring induction motors, when we will use slip ring induction motor and squirrel cage for medium torque. So we will use squirrel cage induction. For high starting torque we will use slip ring induction motors. So the best examples for slip ring induction motors are cranes, hoists, so elevators, and printing machines. And for squirrel cage induction motor, normal induction motors, agricultural pumps, next lathe machines are applications of squirrel cage induction motor. So here in the slip ring, what is the main advantage of slip ring induction motors? So we can insert the rotor resistance, we can vary the rotor resistance in case of slip ring induction. But in case of squirrel cage induction, rotor conductors are short circuited. We cannot insert the rotor resistance in the rotor. So because of that reason, so losses are less in the squirrel cage induction motor, and losses are more in the induction. Losses are more means efficiency decreases. Here efficiency increases. Now, 14th question. Does three-phase induction motor starting mechanism? So it does not require any starting device, because so it does not need any additional starting mechanism. Any arrangement also it does not require. So it is a self-starting device. So induction generator is a self-starting device. But in case of AC generator, AC motor, that is a synchronous motor. So it requires starting torque. So starting torque it requires starting torque. It is a doubly excited machine, synchronous motor. So to start at the time of starting, so we have to give some supply to the field winding and one starting device. But in case of induction motor, it does not require any starting mechanism. It is a self-starting device. It can generate self-starting torque when we give three-phase AC supply. If you give three-phase AC supply, there may be a rotating magnetic field. So automatically mechanical energy will be developed in the induction motor at the time of starting. Next, last one. What is synchronous motor? Same thing. So which converts from electrical energy to the mechanical energy. If that electrical energy is AC, that is synchronous motor. Synchronous motor is the one. So rotor normally rotates at the same speed. So another important thing is, so speed must be constant. So that equals to ns, the speed is known as the synchronous speed, that equals to 120 F by P. Here F is the frequency. So frequency, and P is the number of poles. So depending on the number of poles and frequency, this synchronous speed is we can calculate. Now here the speed must be constant as revolving magnetic field in the machine. So the stator is similar to that is of induction motor, same as the induction motor. These are the slots and consists of cylindrical core type, cylindrical iron frame type, that means cast iron, with having stator winding. We usually three-phase and located in the slots. So like this, so which I have drawn in the previous question. So around inner periphery. Now here stator. So here if you give three-phase supply, R, Y, B, three-phase AC supply. If you give three-phase AC supply to this motor, this device, so rotating magnetic field developed. So here that and induced EMF, mechanical energy will be developed. So mechanical energy developed means rotor rotates with same speed. That speed is depending upon the frequency and number of poles. Here we have total 15 questions. So out of 15 questions, total 15 questions we defined. If you have any doubts in this, you can comment in the comment section below. I will answer to you your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.